Okay. So the first thing is when we are talking about statistic, before I came back to error or whatever, it's about data. Okay. So if you look at this kit, I went through the data and found an 11.7% increase in discretionary spending portion of our family budget. Okay, so this small guy get to know that his parents is spending some increased spending discretion. So I see no reason not to raise my allowance. Okay, so this is what is expected from statistical analysis, because what you are doing for what we are the reason why we are using statistic is for the outcome from the analysis. So because we need to make decision, okay? So the parents at this moment has no reason, has no reason to deny his son request to raise the allowance, because on the data, based on the data, there is a significant increase of spending. So if you can spend more, I see no reason that you can raise my allowance. So this is sort of things that we need to do. We need to use statistic so that we can uh, conclude or make decision. Okay, so it's a, sort of towards the end of analysis when you need to conclude. Okay, so I think, all right. Okay. So, when do you come to data? When do you actually need to use statistic? Okay. So I think this is something that you have come across before. Okay. This is sort of under good lab practice. Okay. Sometimes you practice it without noticing. Okay. So most of you who are working in the lab, okay, or probably in industry. I'm not so sure is everybody working in the lab, whether it's industry, but assume that most of you do analysis. Okay, so when you do analysis, of course, the first thing, uh, you actually, in your case, you probably have the method selected already for you. You have the method selected already for you. It's just that you need to sample, probably. You need to do some sampling because in order for you to run the analysis using the selected method, you have to sample correctly. Okay, so this is just a very general idea of how you do analysis. Is general, is common for all analysis, regardless for food, regardless for agriculture, regardless for biochemicals. These are the common steps. Okay, so think about yourself using HPLC, because this is very common method. Okay, so you need to sample, do some sampling. When you are given some samples, okay, you have to think about how should I prepare the sample. Okay, so you have to understand there is sample processing that has to be done. Okay, so now before you come to data, these are things that you have done. So I will not be talking about all these, but at least I just want to refresh you. These are the things that you have to go through before you come to data analysis, data evaluation, which you will be using statistic. Okay. So sampling, as I mentioned, I will touch a bit on the sampling, but then it is not the main objective of this subject. Okay. Because sampling is a subject itself per se. So if you want to do sampling, we need to study just sampling. Okay, sample processing. What do you think is sample processing? Okay, okay, that's why today everybody seems ready, so I can ask questions. Okay, Marisa, what do you think about sample processing? What do you understand about that? Marisa?
Yes, Prof.
Okay, what do you think?
I think sample processing is about on how the sample is read from as a raw sample. We
Mhm.
can use it for analysis.
Okay, so what involves sometimes?
Uh, Sometimes maybe grinding of the sample.
Okay, grinding, make it into solution form, make sure everything is dissolved, right? Okay, okay. So let's say your method is, as I mentioned just now, HPLC. So you need to properly prepare the sample to suit the HPLC. Okay, so this is just an example. Okay, so this one you have learned, or you have, some of you have gone through in your work, as well as you have done this during your final year project, or you have learned this in final year, probably third year. Okay, during the lab work you do sampling, you do sample preparation, processing to suit the method. Okay, right. So replication also is very important. Okay, because I will discuss about error after this. Why? Because we cannot just believe based on single measurement, right? Single analysis. So we need to replicate. So you know already about this. Most of you know, but it's just a refresh that you need to know why we need to do replications. Because without replication, you cannot do data analysis. You cannot do statistic, like standard deviation, so without replication. Okay. Sample form will, of course, answering the sample processing and removal of interference. Okay, is some of us, some of the samples require you to remove interference, and after all these processes, then comes the measurement. Okay, so definitely this is the ultimate. You measure and you get data. Okay, so let's look at why you need to do all this data analysis and evaluation. Okay, so if we look at in terms of flow chart, you can see process sample is soluble enough. If it is not, you have to carry out chemical dissolution and all that. So I don't think I have to go deeper on this. Let's look at data analysis. So why we need to do data analysis is because of error. So let's go back to the theoretical error that you have learned before. Okay, so there are random errors, systematic errors. Okay, so anybody can refresh back if you remember what's the difference, what's the biggest difference. Hamdi, so you are well advanced in statistics. What's the biggest difference between random and systematic error? Can you give examples, Hamdi?
I'm not expert in statistics.
Tak apalah, it's okay. Based on your experience.
uh, difference between random
Hmm.
and systematic.
Error, ha.
Random usually like when let's say you want to shoot in target.
Mm-hmm.
Example, you shoot six shot, but the target the target that you shot is scattered.
Mm. Okay.
So it's the random. But if you systematic, you shoot six times, but the target six times you shoot is in the center. So it's a very systematic.
Okay. So what Hamdi is talking about is actually this one. Okay. Accuracy and precision. Okay. So, okay. When we do analysis, of course, we want the analysis, the data to be precise and accurate. Okay. So when we talk about precise or precision, we are talking about the how close, yeah, you see this data representing data, how close the data to each other. Okay. But when we talk about accuracy, is how close the data to the target value. Suppose the target value is here, right? Okay. So based on Hamdi talking about, we want to make sure that that is the target. So this is the target value that we somehow theoretically know. Okay. But then if we have the data scattered, not even close to the target. So this one is what we call as neither precise nor accurate. But in this case, we have very close data to each other. It is precise because it is close to each other, but it's not accurate because it is far from the target. Okay, so that is what Hamdi is talking about. So due to this, okay, all right. So go back to random and systematic. Okay. When we talk about, let's talk about systematic first. Okay. So you can find the systematic or random error in the reference book. No worry. Okay. So imagine that you are doing a titration. Okay. So, but it's a manual titration. I'm not talking about the auto titrator. Yeah. Let's say you are doing a titration. Okay. So if you are doing what we call as instrumental measurement, the process of measurement will be exposed to many types of error. So let's talk about systematic error. So the errors are usually propagated from preparation of samples, of course, from the sample preparation until the measurement is taken. So along the process, starting from the sample preparations, sample preparations, measurement, there's a lot of errors coming in. So the errors can be systematic, then the errors can be random as well. So systematic can comes from the method itself. Okay, I'm saying systematic. The systematic can come from the method itself. Okay, which you probably you use a wrong method. Okay, let's say something volatile. If the sample is volatile, the right method should be gas chromatography, for example. But you choose different methods, so that contribute error. But it's systematic because it is contributing the same value each time. Okay. The second example of error is the operator. Okay. Let's say I am colorblind. Okay. And I'm doing titration based on color change. So every time I do analysis, I'm contributing the same amount of error because I fail to see the color change. Okay. So the third probably example of systematic error is the instrument itself is faulty. You don't do any, repair, or you don't do any what we call as not validation. I forgot the word. You send for standardization. Okay, so we don't notice that the instrument is faulty. So that's why maintenance is very important. Okay, somebody is working as lab technologies. Okay, you have to take care of the instrument. Okay, whether they are working well or not. So if we like ignore the operator's capability, the instrument's functionality, as well as the right method, those things are contributing errors, but it is called systematic error because one, it will contribute the same amount of error because you are using the same instrument, which is faulty. So every time you use the instrument, it contributes the same amount of error. And if you're using the same operator who's colorblind just now, he or she also contribute the same amount of error. Okay, so these errors can be eliminated. How? Of course, we can do a better maintenance of instrument, choose the right method, and the third one is probably properly train the operator. So make sure the right operator, he or she is not colorblind, able to read properly. So those are errors that can be eliminated, can be repaired, can be corrected, okay? But what's the biggest issue is when we have random errors. So you see here, some errors can be controlled or mitigated, okay? So as I mentioned just now, by the personnel, operator, by the instrument, and by the methods. But what is the one that is not, cannot be eliminated, okay? All right. So this one is a still example of the systematic. Okay. So random error usually comes together with the uh, instrument, for example. So if you are using analytical balance, okay, we know that there are different types of analytical balance, some with significant figures or numbers, what do you call it? Okay, 2 or 3 decimal numbers. Okay, 2 or 3 decimal numbers. So you know that the more decimal numbers, it is much more sensitive. The less decimal numbers, it is less sensitive. But every instruments, they have their their, what do you call, errors. Okay, so it's not perfect. So every instruments have their capacity, okay, that you need to be aware of. When you read the manual of the instruments, you need to know, okay, they have this plus minus 0.01 error. So that is random error, okay? And then there is a possibility of changes of temperature. Okay, when you do the analysis at cold country, probably it is 10 degrees. And then when you do the measurements in hot country, what probably is 28, 30 degrees. Of course, there will be some difference in the measurements. Okay, there is contribution. So same goes to moisture level in your lab or in wherever that you're doing the measurement. So these will contribute to random error. Okay, which something that you cannot eliminate, cannot mitigate at that moment, because if something comes, I will say naturally, okay, limitation of the instruments, temperature, unless you have a very good temperature control, moisture control. Okay, so this is something, the reason why we have to do statistical analysis. How to solve random error? The data should be analyzed statistically in order to decide on the significance of the measurement and reliability of the conclusion. Okay, so if we remember back the cartoon just now, okay, the son is asking for increment of allowance, okay, based on the significance of the increment of his parents' spending. So so it seems reliable that it is increased. So that's why he asking for increment his in allowance. So very important. Okay, that's why data analysis is very important, because you make decision from that. Okay, so if we wrongly conclude based on the data, then you can imagine the catastrophe, the outcome of your decision. Yeah. Okay, so there's a lot of statistical tool. Okay, so just like what Hamdi mentioned just now, because now we have a lot of software. You just put in the data, you can generate the t-test, you can generate the F value, you can generate the outliers value, you can look at the R squared. So what I'm going to discuss is not how to get the value, because you can get that easily, but is to understand the process of getting the T, the F, the Q, the outliers, the regression value. So what is the significance of that numbered value that you generated? Okay, so I hope that you understand before we proceed to the accuracy and precision. I think because Hamdi has mentioned, so this is accuracy and precision. Okay, so if you remember this picture, this is precision, and this one, how close the target to the target, is accuracy. Okay. Okay, just one more slide before we take a break. Okay, so accuracy. Okay, so let's look at how it affect our life. Okay, so this is quite common when we put our profile picture. Okay, this is the profile picture. Okay, and then when we see the person, the in person, well, it looks different. Okay, the profile picture is not as accurate as it's supposed to be. Okay, so this is accuracy. And what about this? Okay, this one probably is not really affecting you unless you want to make sure you get to know to somebody, and then you want to make sure that he really looks like this. Okay, but let's say the definition of pregnant is protruding stomach. Let's say the definition. So the diagnosis will be you're pregnant. But we know that this is a guy. Okay, and definitely the conclusion that you are pregnant is false. Yeah. Okay, so that's why accuracy is very important, because the conclusion from the analysis will give you your next step. What's next? Okay, so everybody, I think we stop now. Okay, join me back at 8 o'clock. But before that, as I said, that I will give you some, not to say homework, but just to have a look, right? You can open this one. You're still seeing you are now seeing my Google Drive, right? Yeah, everybody?
Right.
All right. Okay. So I'm going to open this one file. So it's already in the Google Drive. Okay. It started with TB. Okay. So during your break, just a quick glance. Okay. Look at this journal. Okay. So just look at the terms. Okay. You can see sensitivity, specificity. Okay. uh, very important. In this case, okay, I would like just to point out that this is a test, okay? A test for ex-pulmonary tuberculosis. What does it mean? Is tuberculosis, but it is not involving pulmonary, is outside our pulmonary system. Okay, so they are using MPT64 antigen. So the analysis is trying to analyze, to conclude whether the use of MPT64 antigen is good for extra pulmonary tuberculosis. Pulmonary tuberculosis is related to lung, but extra pulmonary, it can be related to there are certain parts, bones, central nervous system. So these are the tests they are trying to look at. So you can see that from the test, there are certain criteria they are looking at. So just have a look. Sensitivity, specificity, and in the same paper, you can have a look how they sample. Yeah, how many sample they are taking from the patients, and some are HIV, some are non-HIV. Okay, very important. Okay, diagnostic test. Right? Just get to know with the terms. Okay. Okay, results. Okay. So this is how they presented the samples. Okay, you can have a look. N means number of samples. Okay, and there is p-value. Okay, if you are using SPSS, you can have the p-value. No worry, I'm just introducing it to you. Okay. Okay. Okay, see the words sensitivity, specificity, okay, accuracy. All right. All right. Okay, so just have a look. Yeah, just have a look. This is an example how we use statistical to conclude on whether the MPT64 antigen just now is good for the analysis of extrapulmonary or is not good to go. Okay, so the conclusion is very important. So we can see that in conclusion, the MPT64 was implementable in the routine TB diagnostic in tertiary and low resource. However, this test cannot be implemented until a basic lab structure is available and health systems are strengthened. So there are issues with this MPT64. The method is of immunostaining. Okay, whatever. Okay, so very important from the analysis, from the data that we analyze is the conclusion. Okay, so I hope that you can see how big the contribution of statistic. Okay, so if you are not, if you haven't or you are not using statistic, but in future, this will guide you on how for method development, for method validation, using statistics is very important. Okay, so get back to you after this, 8 o'clock. Okay, have a good rest. Please have a look at this journal. You can open in the Google Drive. So you can just leave this meeting and come back using the same link, or you just leave it open. Okay, all right. Okay, good, everybody. Take a break, yeah? See you at 8. So I hope everybody has enough rest. This is your first class. I understand that it's very tiring, okay? But no worry, okay? As I mentioned to you, as I told you that um, the assessment, uh, most of the assessments are just tutorials, group works, all open books, okay? So there's no pressure, um, not until towards the end, your final exam, that you have to do things. So along the way, you will study, you will discuss, and then you have time to manage all the knowledge before the final exam. So not to worry. Okay, I believe that some of you have left the lectures for quite a while. So probably take some time to tune back. Okay, all right. So what we have discussed just now, okay, I have tried my best to convince you that there is a need for statistic, okay, because that will make sense to your data. That statistic will help you. The statistic, which is the data treatment, will help you to give a reliable conclusion. Okay, give you strength, give you the opportunity to give what is the best conclusion from your analysis. Statistic give you a convincing one rather than you just make random conclusion based on your data. Okay, so we have discussed about systematic error and random error. Okay, so it is very important after this discussion, when you go back to your lab, if you are doing lab work, or you are maintaining some instruments or some quality control, then look at the area that you're working with. Is there possibility of error contribution, and think about whether it's random error or systematic error. So you can just uh, remember that what we have discussed and look around whether you have that kind of error contributing to your workplace. If you're not doing any lab work, you are full-time students, then you can open back your notes, your old notes, and review back and make sure that you know how to differentiate between random and systematic error. Okay, so the one that needs to be treated using statistic is random error, because systematic error, as I have discussed just now, it can be mitigated. It can be resolved. Okay, you can eliminate from the situation by choosing a good method, by maintaining your instruments, by choosing the right operator, for example. Okay, and the next one we discuss is properly define accuracy and precision. So I hope by now you have got all these keywords, the importance of statistics, and due to the random error, it's very important to treat your data so that you have a good conclusion and understanding accuracy and precision. So these pictures tells a story about precision and accuracy. The ultimate aim of our analysis, definitely we want it to be precise. The data should be close to each other and close to the target value. So in this case, the middle area represent the target value. So which means this is what we are targeting, precise and accurate data. So when you do measurements, you look at the data, you have to look at the data, okay? Okay, so whether you decide to proceed or to repeat, yeah? Remember this flow chart, okay? So you need to decide whether to proceed or to repeat. Okay. So you cannot just be happy. That's it. I have got the data. No, you have to decide. Okay, whether you are going to repeat the experiment or the measurement, and then do again some calculation, and after that is, of course, conclusion after the data treatment. Okay, so before you proceed, that is very important. You get the data, you decide, you evaluate. Okay, don't just be happy. Uh, you know, oh, I got the data and that's it, right? Okay, because a good data is very difficult to get. It's very difficult to get, and there's a possibility that we are biased, okay, because we are human being. But in order to get a very good, a very reliable conclusion, we have to be ethical. If the data is not good, repeat and do the measurement again. Okay, so okay, if the data seems good, you have to do data treatment, which is the statistic. Okay, now let's look at example of precision. Just now we look at accuracy. I have made some examples like your profile photos versus actual. Okay, so there is an issue of accuracy there, and then possibility if you misdiagnose. Okay, your diagnosis is not accurate, and you can see the effect, the impact of the misdiagnose. Okay, let's say if you look at what precision. Okay, so if you look at these two cartoons, the left side, this page is intentionally left blank. Well, it's not actually blank, but it would be blank if we didn't have to tell you it's blank. Well, from the cartoon, we know that the statement there is very precise, telling about that it is blank. Okay, it's not actually blank. Okay, it's just a joke. Okay, and this one, this lady. Okay, this is the balance. Okay, sorry, lady, you have gained 1 point. Okay, few numbers here, decimal points. As I mentioned, the greater the decimal points, the sensitive the machines. Okay, so this shows how precise the analytical balance is. Okay, so you need to know there is, I'm sure some of you or all of you knows that different decimal points, different quality of instrument will give you different level of precision and accuracy. Okay, all right. So data interpretation means that you interpret the data is the process of making sense. So I'm sure you know the meaning of making sense. Does it make sense to you? You have the data, but you need to interpret. Okay. So once you interpret, does it make sense? Or doesn't make sense at all? Okay. So you have to think about that. As again, as I mentioned, I would like to tell again that you cannot just be happy. I already completed the analysis. This is the data. Okay, you have to look at the data. The collection may be present, may be present, okay, may be present in various form, okay. So the data, okay, is presented in many ways. So let's look at one of the way is like you have a bar chart, you have a graph, you have pie chart, okay. Those are representation, meaning, sorry, the presentation of data, okay. Because if you put just the data, the values, a bulk of values, you cannot make sense. You cannot, you're not AI. We are human being, okay? We are not artificial intelligence that can crunch the data, okay? But the AI can, okay? So it has to be translated into graph, pie chart, bar chart, okay? So that is what data uh, the collection may be presented in various form, bar graph, line, charts, and many means of presentation. So once it is presented in graph, bar chart, and whatsoever, from there we can make inference, okay, or conclusions. Inference, conclusions based on the presented data. Okay, so let's look at the first example. Okay, now we have bar charts, bar charts, and we have here, okay, standard deviation. Okay, so some of you who has left statistic long time ago, probably you don't remember. So we will discuss about standard deviations, mean, okay? Don't worry. So what does it mean? This guy has a very high standard deviation or error bar, meaning that this data, okay, because we have replicates, remember? Replicates means that the same set of analysis is being done repeated times, okay? Minimum 3 times or more than that, so that we can calculate the error bar. So I'm not going to discuss error bar yet, but from here, okay, you can see that this guy beside, sorry, we just can't trust you. Why? Because the error bar is too high, okay? So there are certain standards that can be accepted. Certain value of error bar, certain range of standard deviation that is generally accepted. Okay, sometimes the values differ from different analysis, different entity, sometimes accept 5%, sometimes accept 10% deviation, sometimes it cannot be more than 1% deviation. So that depends on the analysis, depends on the entity, meaning that which lab, or depends on the analysis, what types of analysis. Okay, so that's why statistic like error bar, standard deviation is very important, because we need to decide whether the data that we have collected reliable or not, or we have to do some evaluation to to remove the data from the data set. Okay, so this tells a story, okay, that give you sense whether the data that you have collected makes sense or not. Okay, that's why we need to do some analysis. Okay, this is something that we do not want to happen. Okay, we have done the work, collect all the data, but without looking first, analyzing first, without repeating, and when you present it in front of the important person. After analyzing all your data, I think we can safely say that none of it is useful. So it's a blunder. So this is something that we do not want, because it will impact, it will give some effect to the what we call as actions after that. Okay, since your data is nonsense, doesn't make sense, so we cannot proceed with the next step. So this is something that you do not want. So it's important every time you obtain data is to have a look, do some analysis before everything is compiled into a report. Yeah. All right. So these are certain precautions, because as I mentioned, as a human being, we are prone to bias. In data interpretation, the main precaution to be taken is to make sure to report a proper, if it is false positive, false negative, and then we have to consider. So probably you are not aware of what does it mean false positive, false negative. We can discuss that later, but the main precaution is there's a possibility that the data that we collect might be false positive, false negative. Okay, this one we will discuss later, but there is a possibility. So proper analysis through statistical methods. So this is what the subject's all about. Correctness of the data analytical process, either based on qualitative or quantitative. So I will show you some quantitative analysis. Data appropriate and adequate for the subject. Okay, this one. Okay, good homogeneity between hypotheses. Okay, because before we start the analysis, before we start the measurements, usually we have some ideas what the value will be. Okay, usually we do that. We know that it's not out of nothing. When we do analysis, we do have some ideas. It should be in this range. But when you have the data overshoot or looks weird, then you have to be, you need to think about it. What can be done? What's wrong? Is the instruments faulty? Or is there contaminations? Okay, we have to do it again. Okay, definitely errors. Errors, we have discussed this now. Another issue, another important thing is negative results. What does it mean by negative results? Is it is not as we expect. Okay, let's say when we do analysis, we expect that let's say the temperature should be rising or the viscosity should be decreasing. That is what we expect from our knowledge and from the theory and whatsoever. So, but then we get opposite. So what to do with the negative results? Do not hide it. Do not throw it away, but keep it first and study. Okay, what are the possibility of mistakes? Or if you even if you repeat sometimes, oh, you still have the negative results. So there might be some interesting things that happen in that analysis experiment. You don't know. So don't throw away results, even though it is negative, but study it. Just keep it first and then read first. All right. All right. So collect your data and make it as clean as possible. Choose the type of analysis to perform because there's a lot of statistical tools and statistical parameters, statistical types of statistical that you can perform. So you have to choose the correct one. Quantitative analysis, of course, qualitative analysis. I will show what is qualitative in science sometimes. This one is social science. Probably you do interview or observation of human being, probably, or observation of animals. Those are qualitative analysis. It is also subjected to statistical. But we are more interested in quantitative analysis because that's what we do. Experiments, we collect statistical quantitative data, a lot of numerical data. Take a step back and think about your data. As I mentioned a few times, you have to look at the data and think about it. Okay, reflect your own thinking and reasoning because you already have some knowledge in you, chemistry knowledge or biological knowledge, and you know that it should be sort of this way, and then that's why you have to think about treat some data and to look at the conclusion. Okay, so in science there are qualitative data. Okay, so qualitative means that you look at pattern. Pictures are probably in this picture is morphological. Okay, so we describe this based on the morphological. Okay, morphological means that we say this is rough surface and we see some cylindrical structures. Okay, those things are that we can comment for these pictures because it is not really quantitative. Okay, but if you see the right side is quantitative. Okay, so you have very high arum and silicon. Okay, so from here you can translate, okay, the data. Okay, in terms of percentage, you can plot the data, you can plot the graph, you can make bar charts, and make comparisons between these two. So one is modified ITO, one is modified, this is screen printed gold electrode, okay? So that from these quantitative results, you can make some conclusion which one has a better uh, better performance due to high amount of silicon or gold, for sake of for the sake of example. So these are things that you can do. And let's say looks at this bar chart. Okay, so this is silicon nanowires. Okay, so there are two things being studied here. One is the number of silicon nanowires. Okay, if you look at here, 1, 10, 20. Okay, and there's other effect as well, which is the pH. Okay, and there's one aptus, but I think we focus on the pH. So if you plot a graph, you can see that you can combine together the effect of number of silicon nanowires and the effect of pH towards the reading of resistance. Okay, so when this is plotted, okay, so how do you study this? Okay, let's say I exclude aptus. I don't want to look at aptus. Okay, so if you look at the colors with 1 silicon nanowires, okay, you are trying to interpret this with 1 silicon nanowires, 10 silicon nanowires, and 20 silicon nanowires. Do you see significant change in resistance? I would say no. Okay, okay, there are a bit of difference, but based on the just silicon nanowires numbers, the significance of difference is not that hard. Okay, there is not much difference. But when you look at the pH effect, okay, 4, 7, and 10. So you have red 4, blue 7, and 10 is the alkaline one. Okay, and then you make comparisons between all this. So there is somehow, okay, significant difference. Okay, significant difference, and the difference is somehow very significant with single nanowire compared to 10 or 20 single, one single nanowire compared to 10 and 20. So from just a bar chart, sorry, from just a bar chart, you can interpret a few things. Okay, if there is a significant difference, if you study different number of silicon nanowires. Okay, and if you contribute, or if you study the pH, if there is any significant difference, if pH is if different pH is affecting the silicon nanowires reading. So from here you can conclude that one silicon nanowire has a significant change in resistance. Okay, when you put it into effect compared to 10 silicon nanowires or 20 silicon nanowires. So that is very, for you probably is not significant, but for certain type of work, the small numbers, even the small value difference are very important. So if we translate that into, this is bar chart. Let's say we plot in graph, okay, and current versus voltage, okay, and this is using, I believe, one single nanowire, okay, and we can see that there is a very significant difference between pH 4, 7, and 10. Very big difference. So the conclusion is the greater the pH, meaning that more alkaline the solution, the greater the current produced from the silicon nanowire. So because the ultimate aim of this study is pH response towards the effect of different silicon nanowire numbers. So the hypothesis will be if there a significant difference, if we expose a different silicon nanowire numbers with different pH, that is the hypothesis. Hypothesis meaning that asking questions, and that's what we want to prove. So from the experiment, we have data, we plot the data, we treat or we analyze this data with certain tools. Okay, from here we are happy to say that pH does affect the pH the different silicon nanowire number does have significantly affected by pH. Okay, so conclusion also is very difficult, okay, to say, but from the study, just a small study, but very significant. We can see the results is significant based on the different pH. So I hope that you can see the flow. Yeah. The hypothesis usually doesn't have to be hypothesis for you. Probably in your lab, you just have objective. What is your objective? Your objective is to analyze the concentration of heavy metals in Sungai Langat, for example. Okay, you need to look at how high the level of plumbum, for example. Yeah. So yeah, that is your objective. So in this case, the hypothesis is the nearer Sungai Langat to certain industry area, the hypothesis that the heavy metal probably higher. That is what you hypothesize. And you do analysis and you do data presentation in terms of graph, you do statistical analysis, and further you can conclude. So now you know the process. Okay. Am I making sense to everybody? Mariam, can you follow?
Yes, yes, I'm following.
All right. So, Mariam, I also would like to know whether your number is, because there are two of you. Yeah, just to check with you. All right. Let me. I just want to save all your numbers. Mariam, is yours is 2189173. Is that your number?
Phone number
Yeah, phone number.
218? No,
91. Not yours. So
no, no.
yours is 234, is it?
It is a foreign number. 234, yes.
Ah, okay. Then that's yours, okay?
Yes,
All right. Okay. I just want, because there are two numbers,
yes,
I believe from Nigeria. So
yes.
you are changing number soon?
No, I have a number that I use. I don't want to change it because
Ah,
of
okay.
my information.
It's okay because we have internet now.
Yes, yes.
Just randomly, I would like to ask, because I need to keep your number. Can I know who is 010542? Anyone with that number?
It's me, Doctor. I'm
Ah,
Sharina.
okay, because your number, I mean, most of you
Doctor?
don't put your name. Yeah. Okay. Nur Ain, yeah. Okay. It's okay. I just do it few numbers today. Right. So I have Nur Ain. Kenapa tak receive? 5429120 kan? Alright, okay. Just one more number, 10111160. Anyone with that number?
It's me, Prof. Marisa.
Marisa, okay. Marisa. Okay. Okay. All right. Okay. I'll keep the others after the next session. Okay. So next week, because Monday will be holiday, as I told everybody, it will be Deepavali. Yeah. So I believe Shalini would like to have with families. Okay. So what I'm going to share, or you can actually browse through. I think I have just shared a playlist, right? The YouTube playlist in the WhatsApp group. Yeah, okay. I hope everybody. So Mariam is giving a thumbs up. So okay. So the playlist is recorded lectures from the previous lecture. So just listen to that. That will be your class next week, which is on Monday. Okay. So by right, if the Putra Blast system is working, unfortunately, for my subject, it is not there yet. I don't know why. So I cannot create attendance list. So it's okay. Once the attendance list is created after this, I will notify you. You can just click your own attendance. Okay, so for today, if the system is okay, I will click for you. For the second time, next Monday, if it is available, you just go to Putra Blast, you just click your attendance, okay, and view the YouTube's videos. Yeah, you can choose any to listen to, but of course, you want to listen to the early parts. Okay, all right. It's 8:30. All right. Let's look at the second part. I believe that you have look at the document just now. The journals that I have shared. Have a time? Did you look at the documents, the journals? Yeah. Anyone? Okay, in the documents, I think you have found the word sensitivity, okay, selectivity, some probably specificity. Okay, so those are some important words. So I'm going to introduce you. Okay, why am I going? All right, those words. What are those words meaning? Because these words are actually very important when you evaluating data, okay? Because some of the conclusions, you talk about sensitivity, selectivity, specificity, okay? So just look at the journal again, okay? So I'm not going to share about this. These are all, I'm trying to relate method validation, yeah? So, okay. In here, because yeah, due to the COVID pandemic in 2020, so people have started to develop a new detection technique. Okay, so some are very advanced. Okay, but this of course has to be validated, has to be checked whether it gives a reliable result or not. So this is important. This is why the statistical technique is very important, because if you misdiagnose, yeah, because when it comes to medical, if you misdiagnose, then the implication is very severe because you'll be mistreated. Okay, so the importance of statistic is very significant when you are doing method validation. So what is method validation or method development? Is when you develop a new method, okay, and then you have to check the reliability of the method. Okay, so how to check the reliability of the method is by comparing the data from your developed method with the standard method. We will explore this again, but I'm just giving you ideas why in method development and method validation, statistic is very important. Not just you run raw material, finished product, okay? But there are other application as well. So there's a lot of new method being developed, okay, for detection, and it has to be validated. So I just want to show you some words that is important when we are talking about statistic, okay, and method development. So we have discussed about accuracy and precision, okay. There are things like selectivity, range, sensitivity, LOQ, which is limit of quantification, LOD, limit of detection, ruggedness or robustness is qualitative, I think. Okay. So this one I have shown you, okay, the flow of the general analytical. Okay, so what is selectivity? Selectivity is the extent that the method can measure the analyte of interest, okay, in the matrix of samples being analyzed without interference from the matrix. Okay, this is very important for all analysis, because when we do analysis, it's not always a clean sample. So if you do river water analysis, you can imagine how the river water is full with extra things. That is called matrix. Okay. Let's say, just like I mentioned just now, we are trying to analyze plumbum, for example. If there is plumbum in the river water, river Langat, for example. Okay. But once you sample the river water, it contains so many other things. So that is what we call as matrix, okay, including other analytes. So selectivity of the method that we develop is the capability of the method which can measure the analyte. Okay, you have to revise back the word analyte. Okay, analyte means that the one that we wish to measure. Okay. Okay. So if the selectivity is very high, meaning that the method is highly selective, okay, it can analyze the plumbum even though there are other metals exist in the matrix or other chemicals like what are supposed to be in the in the river water, the commonly exist in the river water. But if your method is very selective, it can, you know, lower down the effect of the interference from other analytes. Okay, so the effect from matrix. So the analytical response of the analyte in the presence of potential sample is compared with the response of solution containing only the analyte. Okay, this is how we calculate the selectivity. So the selection is an appropriate measurement methodology is a key consideration. Methods even, okay. So selectivity, remember, is the extent that the method can measure the analyte of interest, the one that we wish to measure, in the matrix, meaning that everything is there in the sample, being analyzed without interference from the matrix. Okay. It's difficult to understand the the whole sentence, but if your method is selective enough, you don't have to worry about the matrix effect. Okay. Okay, because your method is very good, even though you have plumbum, you have, let's say, copper, ferrum in that water. The copper and ferrum will not interfere with your measurement. So that is selective. Okay, let's look at another. Okay, linearity. So when we measure, we will have to do calibration plot. Okay, so again, don't worry. Okay, this is just to introduce to you the word. We will learn about the calibration plot, regression, value, and all those. So linearity study verifies that the response is linearly proportional to the analyte concentration. So in analytical chemistry, we usually construct calibration plots because we need to have a linear response between okay, the analyte concentration. Okay, just now I have given example of plumber. So I need to construct a calibration plot using, let's say I'm choosing atomic absorption spectroscopy technique. So I have to construct a calibration plot and I need to know the linear range. Linear means that it is proportional. Okay, again, we will learn about the calibration plot. Okay, so that is linearity, very important if you want to do quantitative analysis. Okay, just now selectivity, linearity, sensitivity. So sensitivity is determined by the slope of the calibration, and generally sensitivity is often confused with reflex to distinguish between two different concentration. Okay, so sensitivity is usually reported uh, in the form of usually limit of quantification and limit of detection. That shows those values will show how sensitive the method that we choose or the method that you develop. Okay, so these values are important for you to use to show that your method is sensitive. The sensitivity and precision will govern how many significant figures. Okay, this one just forget it. But I prefer to choose sensitivity is related to limit of detection and limit of quantification. Range, okay, we just now we talked about linearity. Okay, so it is also related to linearity. Usually it also includes linearity. So the best way to talk about range is when we discuss the example later. Okay. All right. So this is limit of detection, which related to sensitivity just now. So limit of detection should be determined using, okay, whatever. There are few different types, different way to calculate limit of detection. We will learn that because that will answer when people ask, how sensitive is your method? Okay. All right. Limit of quantification, quantification, I think. Quantitation. This is the lowest concentration of analyte that can be measured in the sample matrix. Remember what is sample matrix? Okay, so I give example of river water. Okay, so there's a lot of things in the river water, so that is the matrix. If you are talking about blood samples, there are glucose, there are other like hemoglobins, white blood cells. So those are sample matrix, yeah. And acceptable precision, typically, okay, this is 10 to 20% relative standard deviation, okay? So it's okay. This one we will discuss later, but just telling you some words, yeah? Some words that you're supposed to be familiar with, all right? Okay, all right. This one, I think, something that you don't worry because most of your assignments are open book. So if you forgot, you just study. Okay. What this basic analysis, basic chemistry, okay? For those from biology, I think you also learn about all this. What is the meaning of solution, solute, solvent? So when you get to know all this, it's easier for you to answer the questions, okay? So also same goes to unit. Okay. All right, let me skip this one. Okay, in the lecture notes as well, there are some examples. Okay. All right. Significant figures are very important. Okay. Okay. So I think we have arrived to the final one. Okay. So please get to know all these words. If you forgot, mean, standard deviation, okay? Just get used to it first before we discuss in detail. But I hope today, what should be captured, okay? Stop share this one. The keywords today are the reason that you need to use statistics, okay? Then I hope by now you can explain the difference between random versus systematic error, okay? And really understand accuracy versus precision, okay? So since next week you are going to listen to the videos, okay? I will point out which video is suitable for the next one because you are going to start talking about how to assess outliers, how to at least know what t-test, f-test, okay? So we'll just point out which video, okay? But no worry, we will repeat back. So I hope by now you have get all this and make sense to you. For those who are well versed in statistics is fine. For those who still need to revise back, okay, so at least you have gotten the idea until accuracy and precision. So as well, you need to study the words just now: sensitivity, selectivity, okay, specificity, probably limit of detection, limit of quantification, and some units, because those are the things that will appear in the questions. But not to worry, as I said, for assignments, all are open books, okay? So you can search for resources throughout your assignments. No worry. So final exams only 30%. Yes, there are questions that you have to answer during the final exams. And there are some formulas that you need to know to use during the final exam. Okay, so question from you? I talk a lot.
Doctor,
Yeah,
doctor,
yeah.
if there is a chemical that are very sensitive to light and exposed to light, is it called like random error? How much the chemical exposed to light?
Yes, but when okay, that's what the planning is very important, because if based on our knowledge, we know we knew before the experiment starts that the chemicals are sensitive to lights, then you have to take precautions, right?
I
Yeah, I don't know who's asking because okay. So so you need to take precautions, meaning that you have to cover the chemicals with some things. Okay. You make it dark. The experiment is being done under dark condition whatsoever. So I would say that it is not random. It is systematic, because if you don't prepare properly, meaning that you are subjecting the chemicals to a constant error because you are using the same set, right? But if you cover everything, take precaution, then that it is not subjected to error because it's not random. You have planned. Random meaning that something parameters that you cannot control. but sometimes you can. If you have a good temperature control or moisture control, that is also can be considered sometimes random, sometimes it's not random. But the biggest random that you cannot avoid is the error that comes with the instrument. Why? Because all instruments comes with error. So imagine during your first year when you do, okay, you use burette, you use micro pipette, and then you are to discuss which one is more accurate, right? You remember that? Burette, pipette, cylinder, measuring cylinder. Okay, so within these three, okay, we agree that the pipette is supposed to be the most accurate. Why? Because all these instruments, all this glassware comes with an error. So if you choose the lowest accurate, which is the measuring cylinder, then of course it will contribute some error. So those are random as well. Is it okay? Is it answering your question?
It's okay, that Prof.
Okay.
Thank you, Prof.
All right. Okay. So I think we can have a rest now. I hope that I have made sense to everybody on the statistic. Hope to see you the third week. Second week will be videos. Okay. Any questions before we end? No. All right. So thank you, everybody. Bye bye. Have a nice rest. Okay.
Thank you, Prof.
Thank you,
Thank you,
Prof.
Prof.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.